Okay, so in chapter 3, we're going to talk about describing categorical variables. So chapter 3 is mainly about, we're focusing on presenting and explaining, analyzing categorical variables in a, we can say in a basic form, not in an advanced way. We'll do it from here. All right. So let's move to frequency and relative frequency tables. The distribution of a categorical variable is a list of values with its associated count or frequency. A frequency table summarizes the distribution of a categorical variable. A relative frequency table shows the proportion or percentage in each category. An example, you can see it here. I personally don't like this example. Let me really quick show you on an Excel file how to actually do that. Okay, let's open an Excel file and we can really quick together create a table and see how this works. So let's say we have a, let's have a class, a Bhan 106 class of, let's say 40 students, right? 40 is not round. I want more 50 students, okay? It's better. And in this class, and there are 20 male, and there are 20 male and 30 female students. So what is the variable's name? The variable name is gender. Gender is the variable's name. And it's a categorical variable with two groups, male and female, right? So how do we show this in a frequency table? So you write gender up here, and then down here we have, maybe we start with female, and then we have male, and then here we have total. And up here, so we can color them differently just to recognize that these are titles, is not, or labels. And here, up here, we can have count, or we can have frequency, right? And then after that, we can say relative frequency. And after that, we can have percentage. All right, now those on top, let's just color them. Maybe this color, okay? And all of these, they can be highlighted with the borders and frequency. So I said we have 30 female students, we have 20, I put the numbers the way that everything become very like clear. Total, you know how to get total in Microsoft Excel, right? You, up here you have auto sum. I just say for those who maybe have not experienced it, so AutoSum, or if you don't want to use AutoSum, you forget it, you just type equal to. As soon as you type equal to in Microsoft Excel, it knows that you are going to introduce a function. And what function are we using here? Sum, adding, right? Sum. So sum, double click on sum, and select the numbers you want to add, whatever and wherever they are. Close the parentheses or even no. And that's 50, right? So the totals, I make them also in a different color. All right, so we know how many we have, but what is relative frequency equal to? So I divide each cell, each frequency by total. That's relative frequency, very simple. So divide it by 50. So you can select cell 50 or you can type 50. They both work, but if you select 50, Microsoft Excel works like this. It assumes that you are selecting 2 cells lower. So when you want to copy the formula, it always goes 2 cells lower. So you need to lock on this. And to lock on this cell, you need to press F4. You press F4, it becomes $B, $7. So this is B7. Just type $B, $7. It locks on that number. And always, when I copy the formula, it's dividing by the same cell. So how do we copy? On the bottom right-hand side of the cell, when it's a black plus, click, hold, and drag it down. It's gonna do exactly the same thing for all other cells. So if you had like 20 categories, you don't have to recalculate for each category. You calculate for the first one, copy for the rest is going to be good. And then this one is 1. So the total of relative frequency is supposed to be 1. You want to write it in percent. There are different ways you can do this. I would say you can do exactly the same as a relative frequency. Just divide by 50, and then F4, and copy. All you need to do is to select them. And up here under general, you just need to select percent. They become percent. Good. So that's called a relative frequency or frequency table. So looking back here you have more categories, right? You have different hosts and the frequency they are being clicked and the proportion of it. This proportion is relative frequency. We divide it by the total. So I think that makes more sense now. Reading that, what frequency and relative frequency tables are. And of course, percentage. Bar chart and pie chart. So whenever you have I'm going to have this Word file out here. So please take notes, okay? Because this way, things get much easier to work with. So when you have a categorical variable, right next to it, I say to present it, present using bar or pie charts. If you have a qualitative, categorical, or group variable, you use bar chart or pie chart to show it. No, that's not what I meant. That's what I mean. Okay, so categorical or groups, show it with bar chart, pie chart. This is a common mistake students make. They try to create a bar chart or pie chart for a continuous variable and it doesn't work. Okay, so going back to, how about the continuous variable? Continuous variables, let me write it right here. So in a parenthesis up here, you have groups. Do you know what we have here? Anyone has any idea? What should I put under continuous? Similar to the groups up here. Categoricals are groups. Continuous, what are they?
The scatter plot?
No, not the bar chart, pie chart. I mean, instead of groups, they are some kind of groups, right? We have someone in chat saying something. Variables, no, they are all variables. Even categoricals are variables. So continuous, we can say scale or measures. Make sense? Okay, all right. So for a scale, what do? We do histogram. Histogram. So here, for representing, we use bar chart, pie chart. Because I have less space here, let's make this smaller. I'm trying to put this in everything in one page so you can remember all at the same time. What else did we do for categoricals just now? Frequency table, right? Frequency table and bar or pie chart. So remember that if you have categoricals or groups, when you are presenting them, frequency table or pie chart, and these are the levels of measurement. If you have continuous, what do? You have some kind of frequency table, but we call it distribution, distribution frequency table. And histogram. I put them all at the same time because I just want you to remember it. But later I will explain that, of course. Okay, let's go back to the slides. So bar chart and pie chart is for categorical variables. And we are on the chapter that is about categorical or group variables, right? So the bar chart, what is the bar chart? It has bars, and each bar represents one category. Remember that there is a gap between the bars. If this gap gets 0, that is not a bar chart, that's a histogram. So that's the difference, and it's very important. So it's better to represent bars like this, vertical, not horizontal. And you can see down here, each group has different values associated to it, and that is what creating the bars. Pie chart, for pie chart, we have a circle. We divide the circle into 100 parts, and those percentages that we created, those are going to fill up these different parts of the pie. So let's look at that Microsoft Excel file that we just had and create bar chart, pie chart right here. Okay, so I'm going to use this data to create a bar chart, pie chart really quick. So I select these, the name of the groups and the numbers associated to it, and I go up here, insert, and do you see in the middle it says column or bar chart? Click, select the first one. Select the first one. That's my bar chart. And you can see that this bar chart has female, male here. You can double click and change the title to like gender of students. You can also do some, add some more information here, like data labels. The data labels appear up there, and legend, and change the legend name, and I think that's enough. Okay, you can add the data table down here as well if you want. So there are a lot of things you can add. Not all of them make sense, and you can change the colors or the design here. Okay, so that was a bar chart. How to do a pie chart? Same, exactly the same process. Select these, go to insert, and right below bar chart you have pie, 2D pie, And up there you have different designs. I would select this one really quick. I could create a bar chart and pie chart. Make sense? Any question? Are we good? That was cool, right? And you will have the video, so no worries. If it's not, if I go fast, you can always go back and watch it. Okay, so let's go back to our slides and see. So that's bar chart and pie chart. That's how these bars, this pie is being created. In the example we just learned, we just had two categories, two groups of male and female. Of course, if you have more groups, the process is exactly the same. You select the groups and the frequencies, and it creates bar chart and pie chart for you. We can also create more nicer charts, but I think you just need to know the basics for now, and you can practice it at home and learn more. Okay, I think that's pretty much for, so these are just examples. And this is so easy that I don't want to spend time on it. Please read these topics from the book. And that was chapter 3. So chapter 3 was really cool and quick. Okay, if you don't have any question, let's move on to chapter 4. Describing numerical data. So the chapter 3 was categorical. This one is numerical data, or continuous or scale data. So for scale data, let's see what we have. We collect the data. Nice. So we have median. So median is you arrange numbers in order from lowest to highest and take the location in the middle. So let's just do it really quick here. Have a new table open, and let's have a few numbers. Maybe age of the students, right? And let's have, so we're going from median, right? Median. So age, maybe 20, and then 24, and then 25, then 22. We have a student 19, we have 18, and we have 17, and maybe 23. How many? 3, 3, 2. That's not bad. So, so the first thing I do, I put them in order. Write numbers in order. Come on, order from lowest to high, low to high. So in Microsoft Excel, how do we do that? Just copy these numbers, paste it here, and I just simply sort it. How to sort? On the top right, you have A to Z sort, right? Sort smallest to largest. That's it. Very simple, small to large. So if you have like thousands of data, you can simply just write them in order. So I want the middle point. So this is location 1, location 1, location 2, location 3, location 4, location 5, location 6, location 7, location 8. So which location is the middle location? If we divide this into 2 parts, there's no middle point, right? There's no middle point because we have even number of numbers. If you have even number of numbers, let's color this in different colors. So there's no, there's no middle point. Middle point does not exist, right? So what we do, we add, so we find midpoint of location 4 and location 5, which means I go here, I type 20 plus 22 and divide it by 2, or get the average, or get the midpoint. Average of the 2 in the middle. Divide by 2. Equals to, of course, the middle point of 20 and 22 is 21. You don't need to calculate. So 21 is the median. So median is 21. Make sense? So now let's say we have exactly the same numbers, exactly the same amount, same numbers. So we copy this, and we already have arranged them in order. But this time, let's copy them down here. But this time, let's delete 1. Okay, let's delete 20, 25. So now I have odd number of numbers. Now there is a middle point. That's the top part, that's the bottom part, and that's the middle point. So these are arranged in order, but there is a middle location. That's a mid location. Mid location. The mid location is called median. So median is 20. So that's how median is calculated. Next is mode. So you can read here value in the middle of a sorted list of numerical values, a typical value. Half of the value fall below median, or half fall above. It is the 50th percentile. That means if you divide it into 100 parts, the location that is in the 50%, that's your median. So lower quartile and upper quartile are 25% and 75%. And these are, in fact, so location, so the median was the 50%. Median was the 50%. In this case, 18 is the 25% case. 23 is the 75% location. And these are considered Q1 and Q3. So how do we do that? This is location 1, location 2, 3, 4, 5, 6, 7, right? So 25% of the maximum number here we have is 7 plus 1, sample size plus 1, times 25%. What does that give us? That gives us quartile 1. That equals to 2. So 2 is Q1, quartile 1. So a range of numbers always have a minimum. It has Q1, quartile 1. It has median. It has Q3, or quartile 3, or 3 times 1/4, which is 75%. And it has a maximum. So any data set you have, it always has a minimum point, has a maximum point, has a median, quartile 1, and quartile. So this is the lowest. This is the 25% location. This is the mid or 50% location. This is the 75% location, and this is the highest value. If you calculate these numbers, you can create a box plot. Let's see if the slides have the box plot here. So these are all exactly the same as what I just said. Minimum, lowest, quartile, median, upper quartile, maximum. And if you have these, you should be able to create a box plot. I will show you a box plot later. So mean or average is the arithmetic. You add the numbers, divide by how many of them you have. You already remember that. So variance and standard deviation, I will explain next time, because actually it's a very important topic that we're going to need this for the whole semester. So I won't talk about that right now. Let's see. Histogram. I will talk about this next time. So that's a box plot. If you have the minimum value, quartile 1, median, quartile 3, and maximum, you can create some, and this is something like this. It's called a box plot, and it shows how the data is distributed. So majority of data are in this range right here. I think with the box plots, the box plot locates, box plots locate the median and quartiles and highlight the outliers. The median split the area of the histogram in half. It is resistance or robust to the effect of outliers. That means outliers don't change it that much. That's an example of a box plot. You can see majority of data are in the range of that box. Majority of data are in that range. And these are the tail